So in this video, we'll talk about introduction to motion, and in the series of video, we'll talk about different aspects of motion in one dimension. So let's get started. So the first thing which we are going to talk about is the name itself. What does it mean, motion in one dimension? So what does it mean by motion? So in layman terms, you can say that motion is movement of a body from point A to point B, that is from initial point to a final point. And what is one dimension? So simply you can say that one dimension talks about a line, motion along a line. That is, if you're going in a line to and fro, if you're not taking turns, then you're talking about motion in one dimension. But what is this word dimension? Classically, dimension is defined as the degree of freedom which a particle has. For example, let's take two clamps, and in between them there's a rope attached, and on this rope there are some beads. Now think about movement of this one bead, this bead. Now this bead can only move either in this way or in this way. That is, its motion is restricted to only one axis, and that is why we say that it cannot move in this y direction, as well as it cannot move towards u or into this plane of paper. That is, it does not have any other axis apart from this horizontal line. So this is what we call motion in 1D. So now let's talk about motions in other dimensions or higher dimensions as well. So let's say you are on a cliff or simply a roof. So you are here and you throw a ball. So the ball will go something like this. Now if we talk about the motion of this ball started from this point A, and let's take any other part of its motion. Let's say this is the point B. Now if we talk about their positions, so this ball has changed its position in x-axis as well as in y-axis. So this is what we call motion in two dimension. If we talk about motion of a boomerang, that motion is in x-axis, in y-axis, as well as in z-axis. So that will be motion in 3D. So first we'll talk about motion in one dimension, then we'll go to motion in 2D and motion in 3D by the use of vectors. Okay, so as we start our every lecture with a problem statement, the aim of this problem statement is just to give you the feel that what you're going to learn in this lecture and what you'll be able to do once you learn this lecture correctly and in a proper way. So let's talk about this problem statement. So this says police and police problem. You have heard of police and thief problem. What is this police and police problem? So let's see. So let's say this train is moving at a speed of 60 km per hour. Okay. Now let's say there's a man. Let's say he has one hair. We'll call him Iqbal, right? So this man is not a thief. He's a police. So he's a police. Now this man is running towards the police car at, let's say, 5 km per hour. Now why is he running? Because there's a bomb, let's say here, which is going to explode, and this will explode all of the train. Now the initial distance between the police car and Iqbal is 5 kilometers, and let's say the time in the bomb says 2 minutes or 120 seconds, and at t equals to 0 this police car was at rest, so its initial velocity is 0. Now the question asks, at what acceleration or at what constant acceleration this police car has to move to reach somewhere over here, and this will reach somewhere over here, and this guy will jump from the train and onto the car. So that is what you have to find. So right now this problem might be a little bit complex to us, but once we have seen all the videos, done all the things properly, then you'll be able to do this problem very easily. So let's talk about this question. What exactly is motion? So you might be wondering, why am I asking this question again? We have already defined motion. Motion is defined as movement of a body from one place to another. So if your body is displaced from its position, then we say it has moved, or it was not at rest, it was in motion. But as this is physics, we want to be very precise about our definitions. We cannot just go with any vague statements. So let's see what's vague in this definition. So let's say I'm here I'm standing here and you are standing here. Then you'll say, sir, you are at rest. There's no doubt about it, because I've learned that if a body changes its position from point A to some other point B, then only it is said to be moving, otherwise it is said to be at rest. But am I absolutely at rest? Let's say your friend became astronaut and he went to moon. So he's on the moon, and let's say with a very heavy telescope, he's looking at me. Now, can he say, am I also at rest with respect to him? Absolutely not, isn't it? I am revolving around the sun, I am rotating on its axis. Now, as moon is also moving around the earth, there's also that motion with respect to him. So, with respect to him, I'm doing all kinds of motion, so I'm absolutely not at rest, isn't it? So, there was something that was missing from our definition, that movement of something from one place to another. There was one thing missing, and that was this guy and this guy. So motion can only be defined if only we have fixed our observer. So motion is always relative. It cannot be absolute. It is always defined with respect to an observer who is seeing the motion. Now let's ponder this question. Why everything seems to be moving? Why in the universe everything is in motion? So the earliest reference of an inquiry into why things move about this universe comes from Aristotle, and Aristotle had some idea about motion of things in the universe, and he said there was two types of motion. One was heavenly motion and one was earthly motion. So heavenly motion happens in the skies and earthly motion happens on the earth. Obviously, heavenly motion was pretty simple. Everything in the universe, or everything that glows, revolves around the earth, and that was how those earliest philosophers and you can say inquirers thought about the earth. So that was pretty simple. But on the earth, everything that seems to be moving always kept on coming to rest. And he said then there are some laws in this universe, and one of the laws is that everything on the earth wants to be at rest. Their natural tendency is to be at rest, and if you make them move, eventually they'll come to rest. So the study of motion in physics is trying to accomplish basically two things. One is what is the cause of the motion, and another one is what is the effect of the motion. And that is not only for motion, it is for all physics itself. So what we try to do in physics is to see an event. So let's say any event is occurring, like falling off a body in gravity or heating up of some substance. Any event is occurring. So the goal of physics in this is to find who caused the event, what is the cause of event, and is also to find what will be effect of it. And this is what we call principle of causality. So every event that takes place has a cause and has its effect. So motion is also taught or learnt in two ways. First will be what is the effect of the motion, and another one will be cause of the motion. So effect of the motion is what all of this chapter deals about. This chapter and the next chapter, motion in 2D, that also deals about what will be the effect of the motion. So a body is accelerating, you have to find how much displacement it will do in this much amount of time. So we're not concerned about who caused the motion and what is the basic laws behind this movement of the particle, but we are generally concerned only about its effect. So that is contained in this chapter itself, and this branch is called as kinematics. In this other part, we talk about who caused the motion. That is, we'll talk about what are the laws of the motion. So we'll talk about Newton's laws of motion. We'll define some new quantities like momentum and other things. So this cause of the motion is what we call as dynamics. So that will be your next chapter after kinematics. So first we'll talk about effect of the motion, and then we'll deal with laws of the motion. Now you might ask this question, that why we are learning this? Why we are even learning physics? So my answer would be, physics is the basic inquiry of laws of the nature, that this event is taking place and this event is abiding by some laws of the nature. And how do we know? Because it's not random, it's always doing the same thing. So that means there has to be some law, and it's our basic inquiry to find out things, right? It's a basic need of a man, and that's what makes physicists do their things, that they want to find basic laws of the nature like gravity and electromagnetism. So they don't do it with a purpose that it will be of use in some regard in the future. But in almost all of the cases, it turns out to be beneficial to humankind, maybe some years later, maybe some hundreds of years later, but it eventually does. Like if you talk about steam engine, electricity, then quantum mechanics in field of computing, and like in the fields of computing, okay. Also relativity, all theories are of use right now. So whatever theory we make right now can be of use maybe 100 years or 200 years later. So that's my answer to this question, why are we learning physics? Because it has made the life we are having right now. Everything that you touch, everything that you see on earth that is man-made can be eventually traced back to one physicist giving out some laws of the nature. So everything, every invention is based upon those theories only. So let's talk about this, that why are we learning motion? Because motion is the essential part of everything that happens, no matter the size. Let's talk about big things like sun or earth, satellites, asteroids. All those big things are also in motion. Then if you talk about bigger things than that, galaxies, they're also in motion. Then cluster of galaxies, they're also in motion. So when we talk about universe at a very big scale also, everything seems to be in motion. Even at normal scale, most of the things are in motion, isn't it? Like ball keeps on flying, the trees leaves are moving, the cats and dogs, living things, everything is in motion. Even if you go smaller than these things that we see, like microbes and molecules and atoms and subatomic particles, they're also constantly in motion. So it becomes essential for us to know about motion, how and what are the laws of motion. So let's go and do that inquiry, that what exactly is motion and how do we get more familiar with it. So the first step is to obviously observe emotion. But observation is not just casual observation. We take every data into account. That is, we do some measurement. And for measurement, we need some quantities. So let's define some quantities in motion. Let's say I saw a body move from point A to some other point B. So let's define something before we proceed our inquiry. So the first thing is, what is that body? So body is something which we don't care about. It can be anything. It can be a sheep. It can be an elephant. It can be a box. It can be, I don't care. That's what a body is, right? So that is a body. Now let's define this point as its initial position. We'll call it xi. X defines position and I is for initial. Second thing is xf, that is position final. So body is moving from A, position initial, to B, position final. Now, what all question you can ask? So the first question that arises to mind is how much it moved, right? So that's the obvious question, isn't it? Second question would be how much time it took, correct? Third question you might ask that how fast was it moving, right? And then you can also ask, was his fastness, like how fast was he moving, was it also changing? Like was he going some way faster, then sometimes slower, then again faster? Was it like that, or was he going smoothly with a constant fastness? So all of these things, all of these quantities will define in the next segment. Okay, so let's summarize all of the points that we learned in this video. So the first thing we learned was the definition of motion. So the motion is defined as movement of a body from one point to another. But we learned that it's not that simple. You have to define an observer because motion is always relative. So you cannot say he's at rest or he's in motion, because that would be absolute sense of his motion, that he's at rest with respect to everybody. But that is not the case. So you have to say he's at rest with respect to me, or is in motion with respect to me, or that guy is moving with 20 meters per second with respect to train. So motion will always be defined with respect to a body that is an observer or a reference frame. The second takeaway of this video would be, why are we learning this chapter? Why we are learning motion? And the simple answer is because everything from biggest of scales to smallest of scales are in motion. So it becomes essential to know what is a motion and what are the laws of it. Because you can imagine a universe where nothing is in motion. Let's say everything is at rest with respect to one another. Let's imagine atoms or any particles that you can imagine, but they're not in motion. Everything is at rest. Would there be any change in this universe? Would there be any meaning of time? So those things would not happen. You would not be here if there was no motion in this. So everything that you study, from biology to chemistry to any branch of physics that you have to study, you have to deal with motion. So it becomes essential that you know about it. So the second point would be why we are learning motion. So the third and final takeaway would be that there are two parts of seeing a natural phenomena. That is, inquiry of a natural phenomena has two parts. So first part is the cause of the event, and second part is the effect of the event. And we do that same with motion. So we'll study first the effect of the motion, that is motion itself, what is happening in the motion, what is the acceleration, how much displacement, how